Suppose a plus b plus c equals to pi, where a, b and c are the vertices of a triangle ABC. We need to show that sine of 2a plus sine of 2b plus sine of 2c, that's equals to 4 times the product of sine of angle A, sine of angle B and sine of angle C. Okay, let us begin. So here, this is a problem involving conditional trig identities. Now conditional means, let's say we take the identity sine squared theta added to cosine squared theta, that's equals to 1. Now this is a trigonometric identity because it's going to be true for any values of theta that we choose. However, in this particular problem, we have a condition. The condition being that the sum of the three angles of a given triangle must be equals to 180 degree. That means we have to consider only specific angle values of A, B and C, which is whose sum is always going to be pi, and only for those values of A, B and C, this particular identity is going to be a true statement. So yeah, so let's try to prove this. We'll start our proof from the left hand side and we'll show that this is equals to the right hand side. Here on the left hand side we have sine 2a added to sine 2b added to sine 2c. Now here what we'll do, we're going to add the first two trig identities. Now how do we add two trig identities? So we have a standard formula. If we have sine of angle C added to sine of angle D, this is going to be equals to 2 times sine of the angle C plus D, we divided by 2, multiplied to cosine of C minus D divided by 2. So let's use this. So in our case, we're going to get 2 times sine of the angle A plus B multiplied to cosine of the angle A minus B added to, now we have sine of 2c. Now there is also a standard formula. We know sine of 2 theta. So this is given by 2 times sine of the angle theta multiplied to cosine of angle theta, which means we can expand sine 2c as 2 times sine of angle C multiplied to cosine of angle C. Now next step, what we'll do, we're going to use this condition A plus B plus C equals to pi. So let's do the changes. So we have 2 times sine of, now instead of A plus B, we're going to replace it with a pi minus C multiplied to cosine of A minus B added to 2 times sine of angle C multiplied to cosine of, so here we have a angle C, but what we will do, we're going to rewrite it as pi minus angle A plus B. Right, so here we have used the condition that A plus B plus C equals to pi. Now the reason why we have written in this particular fashion, that's because 2 times sine pi minus C. So this 2 times sine of pi minus C, this is going to be simply sine C, and this is going to become negative cosine A plus B. Here we are using the fact that sine pi minus theta, this corresponds to sine theta. That is the same as sine theta. Whereas cosine of pi minus theta, this is going to be equals to negative cosine theta. Now for sine pi minus theta we have a positive value, whereas for cosine pi minus theta we have a negative value. The reasoning is that pi minus theta lies in the second quadrant, and in the second quadrant sine function is positive, whereas the cosine function is negative. Okay, so let's use this. So we're going to get 2 times sine of angle C multiplied to cosine of angle A minus B. Then we have 2 times sine of angle C. Now cosine of pi minus A plus B, according to this formula, we're going to get a negative cosine of angle A plus B. Fine. Now we have 2 terms. From each of the 2 terms, if we take 2 times sine of angle C as the common factor, this is going to get multiplied to cosine of the angle A minus B minus cosine of the angle A plus B. Okay. So now what we have the difference of two cosine function. So there's a standard formula. So whenever we have the difference of two cosine function given by cosine of C minus cosine of D, so the formula is 2 times sine of the angle C plus D over 2 multiplied to sine of the angle D minus C over 2. So here we have to be a little bit careful. It's d minus c, but not c minus d. So let's take care of that. So we have 2 times sine of c multiplied to, so cosine, so here c corresponds to a minus b and d corresponds to a plus b. So this is going to give us sine. So first we are going to take the sum. A minus b added to a plus b, that gives us 2 times a. And we have to divide by 2. So that gives us simply a. Multiplied to sine of, now we have to do d minus c. So a plus b, from here we are subtracting a minus b. So that leaves us with 2b. So divided by 2 leaves us with simply b. And there's also the factor 2 here. So finally we are getting 4 times sine of the angle A multiplied to sine of the angle B times sine of the angle C, and this is exactly the expression on the right hand side. So we have finally showed that if we have sine of 2A added to sine of 2B added to sine of 2C, so this sum is going to be equals to 4 times sine of angle A times sine of angle B times sine of angle C, and it is true for A plus B plus C equals to pi. Hence proved.